Okay, we're back one more time with AIT 1003. We are going to continue our discussion on the components in a fluid power system. Okay, we've talked about the fluid. We've got to have a pump. We've got to have a prime mover. We've got to have conductors. And the other thing we want to talk to you about right now is actuators. Okay, this is what does the work for us, because after all, that's why we have a hydraulic or pneumatic fluid power system. Okay, we're trying to do some form of work, and we do that through our actuators. Okay, now actuators can come in a couple of different ways. They can be cylinders. I believe I showed you one in a previous lecture, but a cylinder that turns our fluid, our flow of fluid into a linear motion. Okay, linear work there. Okay, with a cylinder. It can also be a rotary actuator or a motor. Okay, in this case, this is the motor where we port our fluid through our conductors. Remember that? Okay, through our conductors into here. It turns a pump, or excuse me, it turns a motor. The motor is hooked to a shaft. The shaft then turns, and we drive some force, like perhaps the wheels we talked about on the ZTR motor. Again, this class is supposed to be industrial, but I try to relate it for things that you see around your house or maybe have immediate access to. But rotary actuators or motors as well. Because we're going to talk about each one of these just very briefly. First of all, the most common is the cylinder. Okay, the cylinder, you've got clevises on each end. There's different ways of different configurations of clevises to hook it to a machine. But basically what's going on is we are porting fluid from one side of the piston to the other and pushing it, and then we'll port fluid to the other side and push it in the opposite direction. Okay, this shows it as well as the arrows with the fluids getting on the back side of the piston and extending that piston out. As we push more fluid, we have to expel this fluid that goes back to our reservoir. And we can reverse the flow. We do that with a directional valve that we're going to get into later. But we reverse the flow, and it gets on this side of the piston and causes it to push back. And of course, the end result is the workpiece on the end of the cylinder is going in and out for a linear actuator. But again, that is a cylinder. That's how it works. I'll talk real quickly. This is a different type of mounting mechanism. This doesn't have clevises. These have got machine pieces right there that are welded to the end of the rod and to the end of the cap. And you got a piston with seals that keeps the fluid on one side of the piston separated from the other. We don't want leaking by or blow by. And so we have seals to keep that right on the inside housing of the cylinder. And the force of the fluid going in here causes it to retract. Can't see it. There's a seal that goes around this rod. It's in this end cap right here, and it basically seals. Around the piston so that no oil can expel. We talked about getting those seals cut. If too much dirt gets in there, that's where we'll start puking it out on the floor. But that is a cylinder. Again, when you come to lab, you're going to get your hands on this with the first lesson too. So yet another example. We're just pouring oil to either side of that piston, and depending on which side we're pouring the oil is whether it's going to retract or extend. Okay, but that is a double acting single-ended cylinder, and that's about the third example for you. Where you will see these a lot of fork trucks. Okay, fork trucks that have the mast that raise the load up and down. Okay, right there. Okay, we're pouring fluid on one side of that piston, and now when we drop it down, we're porting it to the other side to relieve that pressure. But here's an example of something I used to work with. These are what are called billets. They are basically like huge aluminum wind chimes or telephone poles. You call them basically aluminum logs, but they're known as billets. And you extrude parts from radiator coils. Anything aluminum that has any type of shape, form, or contour gets typically extruded from aluminum. And it starts with these billets. But here's what's going on is this billet right here is getting sawed into smaller pieces that the customer will order. He may want 30 inches, maybe want 40, 22, whatever. The idea is to provide it with the billet cut to length like he asks. So they've cut it with the saw. As soon as this one has been processed, these orange arms right here are holding this billet back, okay, waiting. And we've got cylinders on the bottom side. You can't see it very well, but these cylinders are hooked to these arms, and they will retract. And when they do, these arms will retract below the surface level of the conveyor, and gravity will allow it to roll into the the next conveyor and be carried in there to be sawed. I was just trying to give you another example of what cylinders are used for. You know, we talked about log splitters and things like that, and we showed you forklift. That's, you know, those are valid uses for cylinders, but we try to, as we keep moving forward, we're going to try to keep it more industrial. But this, I mean, there are tons of actuators and cylinders in plants everywhere. It's just so many, I can't even name them all. But this is one that I used to work with a little bit. So that's a hydraulic application for you. There's also some hydraulic motors on each side of this conveyor that help drive. This is a chain conveyor. It drives that billet into the saw when it's time to cut the next section out. So these hydraulic rotary actuators are used for the conveyor as well. Again, linear actuators, which are going to be cylinders. You have rotary actuators. This is a rotary actuator. This is used a lot when you have a motion back and forth. You could have possibly used it on these arms, those arms on the conveyor, to rotate back and forth, because they don't travel very far. And if they don't travel like a full 360 degrees or a long linear distance. They're going back and forth. So there's a possibility that it could have used a linear actuator connected to the end of the shaft to make those arms, that your arm would be hooked right here to the shaft, going back and forth, just, you know, maybe about 45 degrees, maybe 90 degrees, something like that. Limited travel. Okay, you got a limited amount of travel. But the idea is you got, it's kind of a combination of actuators. You've got two cylinders on each side, and here's your piston right here. You pour oil to the back side, it pushes that cylinder, and I don't know if you can see very well, but this is kind of a rack and pinion. It's got teeth on the bottom side of this half of the shaft, and there's a 90-degree set of teeth running the other way, and when we push the cylinder this way, it's going to rotate the actuator this way, and then once we've traveled that as far as it will go, we can pour oil to this side, to this piston. It will then push oil this way. The actuator will then move back, and so your actuator can move, you know, 45, 90 degrees, something like that. Not a full 360. I suppose it could if it was big enough, but you know, it's usually for limited travel, but you still need a lot of power behind it. And so what you're doing is you're pouring oil here, and when you pour oil to one side, it's got to expel it to the other. So this will be going back to our reservoir. We'll flip the valve, actuate the valve, put the pressure on this side, shoot this way, the oil will evacuate and go to the reservoir on that side, and it just goes back and forth like that the whole time. But this is a rotary actuator, okay? Another type of rotary actuator as well. Sometimes you'll have, I've worked with these before where wheels, tractor trailer wheels, sit on there, and they would have to be indexed a certain number of degrees, and they would get welded, and so the wheel would get on the actuator and turn, you know, X number of degrees, and this actuator is just going back and forth. It's not going around and around and around. It's just within that 360 degree range. It's going back and forth. So that's a rotary actuator. And you know, again, those are the three types. And I just kind of wanted to make you familiar with those. You're going to get into these when you come into the lab. Okay. Speaking of which, you want to make sure you schedule your lab. I hope you've been taking notes with this. Again, we've been talking real general terms in this particular lesson. Lesson 2 and going forward, we're going to get a lot deeper. We're going to start getting into some calculations and some math, and you're going to kind of see how we're able to develop these great forces we've been talking about. We're able to create a lot of power and a lot of force to get a lot of heavy work done with hydraulics and also with pneumatics. But you know, you get your hands on these components now, and we're going to start calculating how much work can they actually do based on how they're designed. So that's going to be it for right now. This should conclude the last of the 3 lessons here, or the 3 videos, excuse me, for this lesson. Again, make sure that you read your textbook. Make sure that you schedule a lab appointment, because this is when you're going to come in and start hooking things up and getting more familiar with all the components we talked about so far. Okay, and again, all of this builds one right after the other, so you're not going to learn this stuff for a test and forget it. You need to hang on to it up here and on your paper and your book, however it helps you best. But that's going to take care of it right now. Schedule your lab appointment, make sure you do your reading, and check your course schedule, and that will tell you what is due and when it's due, okay? So it's all there on Blackboard, so take a look at it. If you have any questions, got any comments, or if you just need to, got anything you need to get hold of me for, either email me or call my office. All that contact information is in Blackboard too. But other than that, we will see you on the next lecture. And again, just get hold of me if you got any questions. Thanks for watching, and we'll see you next time.